Okay, in section 5.7, we're going to kind of talk a little bit more about linear models, but really in this section, we're going to look more at finding zeros of functions. Okay, section 7 goes along with line of best fit, which is what we talked about in section 5.6. And instead of just kind of revisiting that idea, we're going to focus more on finding zeros here. So the first thing you need to know is, what is a zero of a function? Okay, what does that mean? It's kind of an awkward phrase. Okay, so what a zero of a function is very simply, it's an x value for which f of x equals 0. Okay, so the zero of a function, x value for which the value of your function, f of x, equals 0, or y equals 0, same idea. Okay, so that's what a zero of a function is. So let me kind of rephrase all of this and kind of connect it with some things that we've already discussed throughout this class. Okay, so if we look at the next section here, okay, we're going to look at relating solutions of equations, zeros of functions. Let me delete that real quick. There we go. Okay, so in chapter 3, we learned how to solve an equation. 4x minus 4 equals 0. You all know, add 4, divide by 4, x equals 1. Okay. In chapter 4, we focused on how to find the x-intercept. Okay, so again, let me rephrase this. So in the first part here, we learned, okay, plus 4, so 4x equals 4. Divide both sides by 4. That tells me that x equals 1. In chapter 4, we looked at, okay, here's my graph. I know how to graph this thing. Okay, whoops, x and y. So replace this guy with y. So y equals 4x minus 4. Y-intercept is negative 4. And slope is positive 4. So up 4, right 1. Plot that point. There's my graph. Okay, and now what we're going to look at in chapter 5 here is finding the zero of a function. Okay. And what the zero is, it's the same thing as the solution here. It's the same thing as the x-intercept here. Okay, except now what you have to know is, when I give you a problem like this, when it says find the zero of a function, and this is your function, you know, replace this guy with 0. 0 equals 4x minus 4, and now it's no different than what we just did up there. Okay, but really the thing I want to get across to you here is that a zero of a function is really the same thing as the x-intercept of that particular function. Okay, and obviously in a linear model, your graph can only cross the x-axis at most one point. Okay, it could be 0 if it's a horizontal line. Okay, but most of your lines are going to cross at one point. So we're just going to look at a few basic examples here of finding zeros of a function. Okay, and we're going to call it a day. So example 1, part A, says f of x equals 16x minus 4. Find the zero. That means this guy is 0. All right, so when I do that, I get 0 equals 16x minus 4. And then I'm confident that you all know where to go from here. You add your 4 to both sides. So you get 4 equals 16x. Divide both sides by 16 to get x by itself. X equals 4 over 16, which reduces down to 1 over 4. So in other words, if you were to graph this function, you know that your x-intercept is going to be positive 1/4. Okay, if I look at part B, again, same idea, find the zero. 0 equals 2 minus 4x. Subtract 2 from both sides. Negative 2 equals negative 4x. I got to get x by itself, so I got to divide both sides by negative 4. And that tells me that x equals positive 1/2. So again, what does that mean? It very simply means that your graph of this line would cross the x-axis at positive 1/2. And for part C, 0 equals 1/2 x plus 5. Subtract your 5 from both sides, you get negative 5 equals half x. I got to get rid of the 1/2, so multiply by the reciprocal. 2 over 1, we're just 2. So these two things cancel. That means x equals 2 times negative 5, which is negative 10. All right, I know I went through those quickly, but again, this idea of finding zeros, once you understand that this just means plug in 0 for this guy, really it just becomes solve an equation for x, all right, which is something that we've been doing for a while now. Part D, obviously a story problem, says the percentage of Y people the percentage y of people in the U.S. that use public transit to commute to work can be modeled by the function y equals 0.045x plus 5.7, where x is the number of years since 1983. Find the zero of the function. Explain what the zero means. Okay, so what this means very simply is plug in 0 for your y. So 0 equals 0.045x plus 5.7. Okay, so now we subtract 5.7 from both sides. Whoops. So you have negative 5.7 equals 0.045x. Divide both sides by 0.045. So those cancel, and so your x-intercept here, or your 0, is 5.7, negative 5.7 divided by 0.045 is negative 126.67. Okay, that is your 0. And so what this means is very simply, understand this. When is y 0? Well, what does y stand for? It says the percent y. So y is the percent of people that use public transit. Okay? And so when y is 0, that means that 0% of the people in the U.S. use public transit. Okay? So in other words, when the percentage of people is 0, when nobody is using public transit to commute to work, okay, it crosses the x-axis at negative 126.67. What does that mean? Well, 1983 is our beginning year. And if it's negative 126.67, that means subtract 1983 by that. And so what this essentially means is, back in, if I do 1983 minus 126.67, so back in 1856, okay, 1856 is the last year when nobody used public transportation. So again, this section, the idea is just understanding what zeros are, how they relate to a graph, and how they relate to things that we've already discussed. So really nothing incredibly new in this section, but just a different way of looking at the same type of problems.